Welcome to today's FS Club webinar. I'm Zoe Buckingham, an international marketing consultant with a background in diverse private and public sector projects. It's my pleasure to be able to chair this event today and to introduce you to Dr. Ian Wadey, Vice President of the UK and Ireland for expert.ai. Before we move on, I would like to thank our very generous sponsors who allow us to range widely and freely across technology, economics and finance, a really interesting mix, and that's what contributes to such great content. I also wanted to mention some housekeeping notes. The slides are available to download in the chat and on the website, and we'll be holding a 20-minute Q&A session after Ian's presentation. So please make sure to use the GoToWebinar chat facility to send your questions into me. I will then feed them into the conversation. Lovely. So without further ado, Ian, the floor is yours.
Thank you very much, Zoe, and it's a pleasure to be speaking here at the FS Club. We're going to talk about next generation natural language processing, and we'll talk a little bit about touch on a couple of approaches and the history, and how we can improve that by combining these approaches in a hybrid AI approach. So next slide, please. We thought we'd start off with a question to see how well you understand the domain, and that will sort of steer some of my explanations a little bit. So we've got a couple of questions here for you. Which branches of natural language processing are you familiar with? The symbolic, which is the mixture of knowledge graphs and linguistic analysis, machine learning, natural language processing like transformers, or both, or neither?
Thank you, Ian. Yes, if everybody can vote, it would be really helpful in terms of us understanding your knowledge at this stage. Just another few seconds.
Perfect. Actually, so we've got quite a mixed audience there with a number of people understanding both. I'm quite surprised with the symbolic as well. So that's very interesting, and I will try and cater to everyone there. I will start off, I think, leaning on a couple of previous presentations to the FS Club, which I thought were really interesting, and kind of lead into this presentation in two ways. So first of all, Dr. Robert Hercock's presentation, Text to Intelligence, the Future of Knowledge Graphs. He was talking about how advances in natural language processing and deep learning, along with network dynamics and improvements in network dynamics, has meant that we can curate knowledge graphs much more effectively. And what was particularly gratifying in that presentation as well is he defined a knowledge graph, or used a definition of a knowledge graph as a knowledge graph consists of a set of interconnected typed entities and their attributes. And that quote comes from one of our own research directors in expert.ai, based down in our research center in Spain. So there was a nice sort of hook there, and he kindly let me make a reference to his presentation in this presentation. But if you want to know more about knowledge graphs, I'd go back to his and have a look at it. And then I thought the other one that caught my attention, particularly in this space of natural language processing, was a very recent presentation by Jason Voss, who was talking about deception and truth, and the fact that he's got algorithms that can identify in text whether the text is more deceptive or more truthful, and he can scale it. And then he was putting together investment strategies to mine that alpha that he could identify, and he could show that actually he was getting better returns when he could lean on more truthful companies in his portfolio than the less truthful. And I thought that was a really interesting and fascinating use, and it's one of a few that I've seen about companies, hedge funds and people trying to mine. He runs this sort of process, and he again kindly runs a company in California doing this, but he's kindly let me reference him as well. But I've seen other articles where people have been trying to mine the feedback and of employees on their companies, and see if there was any correlation and alpha there. So just a couple of examples feeding back on previous webinars. But let's move forward. And just a little bit sort of into what we mean by hybrid natural language processing. We talked about a little bit about knowledge graphs. This is the book that Jose Manuel wrote in the middle, leveraging Symbolic AI. And then he's written a recent book on a practical guide to hybrid natural language processing and how we're bringing this together. And we'll go into this in more detail. I came across, I was given the robotic process and cognitive automation book at an event I did a couple of years ago. And then I was flicking through it and happened to notice that chapter 7 is dedicated to our use case at Zurich, where we process medical reports for automotive insurance claims. And we're able to digest from a doctor's medical report the ICD codes that are associated with it, the durations of the treatments, and therefore quantify the medical claim or the insurance claim. But just to sort of widen the conversation a little bit, hybrid natural language is a concept that's sort of really taking hold. Gartner refers to it as composite AI, and there's a link in the webinar to one of their presentations. And Forrester talk about the need for both machine learning and symbolic approaches, and we'll come on to that in a little bit in a moment. And then the Messer M&E daily article discusses Dow Jones' use of expert.ai as well. There's one a publicly available presentation of one of their directors speaking about their use case. So let's move on to the next slide, and we have another question for you. Which is, so what are the obstacles to using natural language processing? Is it the lack of data? Is it the challenge of annotating the data? Is it the challenge of creating the knowledge graphs? Is it the explainability, or none of the above? How are we doing, Zoe?
Well, we seem to be, we don't seem to have all the results in yet, so just encourage people to put the results in as quickly as possible. Oh, annotating data, interesting.
And explainability as well. So the
quite strong, isn't it?
Yes, I'd agree. So let's build on that topic, and actually I think the hybrid approach will start to sort of lean on a couple of those challenges. So if we go back to the Forrester conversation, Forrester actually their quote is, "Machine learning has a knowledge problem," and I found that in the recent or the last State of AI, that's state of .ai report, there was a couple of really interesting insights in that presentation, and I'd like to draw on two of them. One is the correlation they showed, the power law, between the amount of data that and the performance of machine learning AI natural language algorithms. And it implies that as you increase performance, you need an order of magnitude more data to get that performance. And we can see this in GPT-3 was reported to have 1.75 billion parameters in it, and GPT-4 is reported to is apparently got about a trillion parameters in the graph, and that would imply that actually that relationship between data and performance is a feature of that approach. And the challenge that we get in a lot of use cases, and we've seen it with a lot of our customers, is the data scarcity, the lack of data available to train algorithms. And I've seen it in other organizations as well, where you're talking, the engineers get a little bit frustrated because you say sort of Google's got all this data to hand, but in the company use cases, the customer interactions or whatever it is, you end up with many orders of magnitude less data. The other piece that they talk about later on in the report is that causal reasoning is a vital missing ingredient of applying AI. And they go on to sort of talk about AI approaches purely associative and strongly correlated. And this is another challenge. You're not you're uncovering relationships in language, but you're not and associations, but you're not uncovering the causal reasoning. And a linguistic approach allows you to surface the causal references that's available in the text that you've got. And then we have the other challenges. Boston Consulting Group saying that 90% of projects never make it to production, and 96% experience problems with data quality. And there's another interesting report by Google. They say everyone wants to do the knowledge work, no one wants to do the data work. And they talk about data cascades and some of the challenges caused by poor data quality or poor data preparation. And I think that therefore leans to some of the challenges that we were seeing a little bit earlier in the problem with annotating data, for example. So let's move on to the next slide. So and that's and we also highlighted, you as an audience highlighted the problem with explainability, how machine learning algorithms can be black box, and we can now see sort of approaches as to how we can convert that black box into an explainable model. Go on to the next slide. So let's dig a little bit more into the language, the challenge with language. I mean, it's kind of interesting to note that that language in this alphabetical written form with sort of abstract or copies speech a lot more than previous sort of models has been around for about 3,500 years. And it's also interesting to see how the body of human knowledge has sort of evolved and grown through the Greek philosophers and to the modern day since the invention of alphabetical language in the near Middle East. But some of the challenges that machines have in understanding language that humans can cope with is, first of all, we use words in we use multiple meanings for words. So let's take the simple example of Jaguar. Do we mean the car, or do we mean the cat, or do we mean the programming language? Do we the word course? Do we mean a golf course, or something that we go and learn something on? And the knowledge graphs are very good at helping sort of understand in the context of the other words around, much like a human would, is what concept are we actually using or associating with when we use that abstract word for it. Another good example of struggles of language is grammatical anaphora. And a grammatical anaphora is the abstract reference to an original concept. So we don't like in text writing a word several times in a piece of text. So for example, the FS Club event, blah, 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 we wouldn't say the FS Club every time that we wanted to refer to it. We would say that event or it and things later on. And we do that an awful lot in text. So if you think about a piece of text, you're going to have 2/3, 3/4 of the concepts actually referred to by a pronoun or some abstract means rather than the original concept and word. And therefore, we really do need to understand and disambiguate the language to be able to understand those concepts. And the knowledge graph disambiguation approach, which has really sort of been around since the turn in the millennia and research sort of earlier than that, allows you to do that. You can use a morphological analysis, syntactical analysis, semantic analysis to start surfacing the nouns, the verbs, the objects, the noun phrases, the verb phrases, the preposition phrases in the text, and that allows you to start understanding. And I suppose that sort of grammatical construct is a little bit like the Broca area in the brain. If you read some of the psycholinguists like Steven Pinker, who is a disciple, I guess, of Noam Chomsky. He will sort of say that the Broca area is where we process grammar, and that's where we're putting all these concepts into an order with other concepts and nouns and verbs, etc., all concepts, and starting to make sense of it. And by using that logic, we can start breaking it back down again into noun phrases, verb phrases, objects, preposition phrases, and start working out who is doing what to whom. And then you're starting to get to the basis of the causal reasoning that is associated and written into the text, rather than having to sort of do that sort of correlation type approach that might otherwise be there. So let's move on a little bit. So we understand some of the problems in language. Let's move to the next slide and think about how we handle it. So there's two main approaches: the symbolic approach and the machine learning approach. And let's dig into each one of these. So go on to the next slide. So the symbolic approach, we've talked about knowledge graphs. Google embedding knowledge graphs into their search engines in 2012 to get that finessing. They focus on entity knowledge graphs to get that focus and nuance in their search. But the pros is it's easy to understand. You get explainable results. The difficulty with this is the curation of a knowledge graph in the first place. And then the reasoning engine is a set of language that a knowledge engineer needs to learn and work with. Let's go on to the next slide and think about the machine learning approaches. And the machine learning approaches, if you've got the annotated data, and we've already sort of seen the perception of annotations as being difficult to do, then you can feed this into the model and let the model do the heavy work rather than the knowledge engineer. But you get the lack of explainability. It's computationally very inefficient. If we've done various studies, you can see the amount of computation you need for building a machine learning model and the results, and the latency in that model as well when you retrieve those results, versus a symbolic approach, which is much quicker and much more computationally efficient. When you turn it on, when you turn on a machine learning model, you see the lights dim slightly across the world. The sunbeams sort of dim a little bit, and then you get the answer. But what we'll find, if we go on to the next slide, and I haven't done it in this presentation, but you map those pros and the cons together, and you start noticing that the pros of one is associated with the cons of the other, and vice versa. And therefore, we can put these together and really start creating a win-win model. So what we find is machine learning. In fact, let's go on to the next slide, and we'll show how this win-win sort of works. We've built a platform that allows you to do natural language processing and go all the way from a pure symbolic approach through to a pure machine learning approach, or do a mixture between them. And that the symbolic can support machine learning. I think a couple of good examples of that is automatic annotation. So you can build a simple reasoning engine and I think that disambiguator, if you think about it in machine learning terms, effectively it's a linguistic features engineering machine, and you can use that linguistic engineering machine to surface the features on the documents and automatically annotate your documents, and then you have a human just go in and sort of check that those annotations look correct and make some modifications. So that really speeds up the process of annotations and addresses that challenge that people were perceiving when we asked that earlier question. Another really interesting area of this is you can use the linguistics features engineering machine to actually surface features out of the document which are really easy to surface. I mean, actually, it's not just the easy ones. You can get a lot of complexity out of the documents, and thereby you can now start feeding in those new features into your machine learning model, and that means the machine learning model can get to the results it needs to get to good results with a lot less data and a lot less training. So you make it computationally much more efficient and much more effective. So you start to overcome the data scarcity problem. And then we've got the other way, machine learning supporting Symbolic. We've got a great use case. In fact, I'll come on to this in a little bit more description in a few slides. But the machine learning supporting the Symbolic, and therefore out of the black box, you can get an explainable model. And then a little bit like Dr. Robert Hercock was saying, we can start using machine learning to support knowledge graph curation. So we can take that core knowledge graph that we've got and we can add specific domain knowledge into it for each of the different use cases that we're working with, and we can use machine learning to surface the network of data and the ontologies, etc., from the documents. So if we go on to, let's go on to the next slide, and we'll think about some practical applications of this.
Now, Ian, we've only got a few minutes left before questions, so I just wanted to encourage you to make sure there's time for those, if that's okay.
Yeah, I'll rattle through.
Thank you.
So Symbolic, this was a model that we did for financial press releases for one of the big information providers, and we were trying to find buyers and sellers in a financial transaction and the advisory firms. We were able to annotate the press releases semi-automatically with the linguistic engine for the machine learning. We were able to identify features in the press releases that we could feed into the machine learning. So the machine learning was very accurately able to identify buyers, sellers, and advisory firms, legal advisors, consulting firms, etc. And then because that's associative, and we've got the verb objects, the subject verb object relationships and the causal relationships, we were then able to build the relationships in the model and work out which advisory firm is supporting which of the parties in the transaction. Let's look at the next example. This was a similar sort of example of Symbolic supporting machine learning, identifying change in control in financial articles or reports. There has been a change of control is easier to identify, and as it's more frequent and more obvious. The no, there has been no change of control in the swapping of shares is more complex. And what we were able to do here is inject some symbolic rules into the machine learning model, which help the machine learning model understand which case was no, and therefore improve the performance of that model by 25%. Let's go on to the last slide on the examples, and then we've got one more slide after that. So hybrid, this was the other example I wanted to come to, where we've now got machine learning supporting Symbolic, and here we had it's kind of a library services, and they've got about 50 documents per category, so data scarcity again issues. We were able to use machine learning clustering algorithms to identify the taxonomies automatically, and then from the machine learning model, we were able to automatically write the rules. And then when we had the rules set written, now we've turned black box into explainable, but we can also tweak the rules to improve the performance. And then let's just go quickly through the last slide, a few of the examples. We had another question. Should we do the question, or should we?
Perhaps let's skip the poll for now, but we could perhaps integrate the poll into our Q&A actually, because that might be quite fun. Okay. If you wanted to just conclude on on this particular area.
Yeah. So last slide then. There's a couple of sort of use cases and examples. The use cases tend to fit into two broad categories: intelligent automation, where you're processing transactions, documents in a transactional way, and insight engines, where you're surfacing data from big corpuses of documents. So enabling faceted search for people like Bloomberg, Wolters Kluwer, did a recent webinar with them. So DigiPublish, I think that was, but the surfacing and looking at finding regulations, for example, what the regulations that are applicable to companies that they for compliance reasons, or scientific journals, finding all the surfacing searches, very nuanced searches, improving recall and precision in searches for scientific publishers, or some of the big information providers and media agencies like Associated Press and others. Customer interactions, we're working with ING and Rabobank, are doing vast volumes of customer emails and categorizing those. Sentiment analysis, we've already talked about the truth idea. The sentiment as well, we did an analysis of the US election last year and was able to define how close the election was going to be, and predicted the result much more closely than a lot of the pollsters by analysing Twitter feeds. Anti-money laundering, politically exposed persons, special interest persons, bad news, repository of documents using open source news channels and proprietary news, and be able to surface which John Smith are we talking about in which context, and is that our customer, is that not our customer? And then in the intelligence sector, market intelligence, supply chain intelligence, looking at asset protection, equipment and people, brand protection from your that might be affected by your suppliers, and obviously the intelligence sector as well. But I will pause there, take a breath, and let's go for some questions.
Wonderful, Ian, that was so interesting, and thank you so much for explaining an area that's so relevant to the application of AI in a number of different fields. You were covering an awful lot of interesting sectors in that last slide, and perhaps we can dive into those with some of the questions. We've had a question from the audience, Ian, just asking about, I guess a lot of people are sort of trying to work out how different companies use different techniques. And the question's around a technology called, or a company called Deeply, D-E-P, and then a capital L, DeepL, a translation service. Is that one that you're aware of? Do you know which kind of model they're using at the moment?
No, I don't know the specifics on companies like that. Interesting enough, you can use sort of pipelines of processing. So we do with some of the media companies, and there's other use cases with video where we can use speech to text to analyze the text in the video, and then tag at various points in the video where certain things are said. So it makes video a lot more searchable. So that's speech to text. And then we've got 12 knowledge graphs in 12 languages, so we can do those. Where we come across other languages, we'll use a translation services as well, and there's some very effective ones.
Thank you. How does symbolic learning kind of keep up with the evolution of language? I mean, as far as I can see, especially with the English language, it's evolving all the time, and it must be quite difficult to update your models to keep up with those changes in not just in the evolution of vocabulary, but in syntax and grammar.
So I think there's a couple of ways there. I mean, the knowledge graphs are always being maintained all the time, but we've also got models where we can import ontologies from customers and link them in with the knowledge graph, so you can now expand the search and what you're searching for and the concepts you're surfacing in the documents. And then you've got the machine learning approaches as well to surfacing more data in there. And then in the analysis of the text, you're already finding in the context of the words and the morphology of the words, whether you're working with a verb or with a noun, and be able to disambiguate where a word might look like a noun or a verb because of the context of the other words around it. So you're able to then cope with the quite a lot of the ranges of and nuances in language that you would come across.
Thank you. And I was interested also in you were talking around the different industries and the way that they have been using your sort of hybrid approach and symbolic AI in order to. What applications are there, do you think, for the law?
So I missed a little bit of the sound there for the last bit of that.
I was just interested in what do you think the applications could be of this technology for the for lawyers and for possibly even sort of law enforcement?
So very interesting, and the sort of law enforcement actually is we're working with some law enforcement agencies in this. I think sort of come to the lawyers first. There are use cases we're working on where we can identify clauses in contracts. So despite the fact that the wording of those clauses may be different wordings, and there's a similar use case in insurance, which is policy review and checking global policies versus local policies and ensuring the right clauses are in the policies. So you can use this sort of language processing to automate quite a bit of paralegal work in identifying the completeness of the contract. There's a use case with a company that is wanting to make sure that their contracts are compliant, and which means that making sure that there are certain clauses exist in the contract, for example, GDPR clauses, and that they've passed those clauses onto their suppliers, and therefore they've remained compliant with all those laws.
Yeah, that's a great use of it, isn't it?
I mean, I think on the law side of things, it's more the search engine sort of capability as well. The being able to look at a corpus of news reports, Twitter feeds, social media, proprietary news sources, international news sources, and then really be able to sort of surface information about people that you're looking at, and because we know which John Smith we're talking about, we can start surfacing the right John Smith and the information about that John Smith from various different sources. I hope we haven't got anyone called John
Yes, that's
Smith.
great for compliance, isn't it? Yeah, absolutely. The other thing I was interested in was with obviously you're sort of creating these models so that certain characteristics can be sort of identified in terms of the way that people use language. How do your tech team keep up with research into maybe sentence construction that could be considered to be dubious or requiring further investigation, which could then feed into, for example, an analysis of report and accounts? Is that the kind of thing that your team will kind of stay on top of?
So we're doing research on language all the time, and I think the probably an example that's related to that is identifying fake news. So I think we've got a blog post on our website around fake news reporting, and there you're studying the style and the nuance of the language to surface that. And we've got a feature of our platform, and people can go onto the platform on try.expert.ai and look at various of these features. But you can look at right print, as we call it, which will analyze the style of what's been written, and also you can sort of classify the level of education, if you like, of the person who's written it, or associate the style with a certain level of complexity and maybe sophistication.
Oh, how interesting! And in actual fact, we've had a question. We've had a question from somebody called AI. I'm not sure whether they're an artificial intelligence specialist, but they've said, what's the level of accuracy of these models you use? Could you talk about the types of errors that you've encountered as well?
So I think a good example of that is I did a presentation with an AI lead in one of the big banks recently, and he was talking in that presentation about how in email classification the human beings were 80 to 85% accurate, and our approach, the symbolic approach, and it was a pure symbolic approach in that instance, was 90 to 95% accurate. And we've had sort of similar things where there was another email classification case we were doing, we had to process about 5 million emails, and the and we were struggling. They were struggling. The partner was struggling with data scarcity. There wasn't enough to sort of surface the results they wanted. But again, with the symbolic approach, they got to very high levels of accuracy in the 90% cases. So it's an interesting sort of topic, accuracy, because a lot of people want machines to be 100% accurate without recognizing that people are sort of 80% accurate. And then you've just got to think about also risk in email classification. If 5% of your emails are going in the wrong direction, you can reroute them. But if some critical decisions are being made on these algorithms, then you might want to build a bit more resilience into the model and have a couple of voting sort of mechanism, much like you do with humans. There's some sanction screening processes in banks, for example, where you might have 4 people actually looking at the same transaction and kind of voting on it to make sure that that it's been processed accurately.
It makes sense, doesn't it? And then just the human eye at the end to look at things from another perspective, to work out whether that's the person that they're concerned about really is someone they need to worry about. Yeah, and actually somebody's asked how your models would deal with somebody who was actually kind of learning from the questions that they were asked last time and coming up with cleverer answers next time. Because I guess we've all been in that situation of answering questions and realizing that we can kind of slightly buck the system.
Well, there were some good examples of this a while back with machine learning algorithms that were learning on the fly, and people were able to ask them certain questions that actually then made them quite abusive or biased. I guess the advantage here of symbolic approaches is you've got control of the rules, and a lot of the use cases are more about identifying the intent at the beginning of a chat, so you can then route the individual down the correct chat channel to answer their query. So I guess sort of yes, machine learning has that sort of challenge. Symbolic approaches don't. And that's where sort of the combination of the approaches can help address that issue.
Thank you. We've got a question that might be our last, depending on how long it takes to answer, from Maury Schenk saying, do you have any comments on the implications for NLP development on the fact that large pre-trained language models like BERT and GPT-3 can work across a wide variety of applications with relatively limited data, rather than requiring training of application-specific models? If this trend continues, how will it affect the need for symbolic and hybrid approaches? We're talking about these major systems, kind of innovations in the area.
I think I mean, you can tackle that from a couple of different directions. One is GPT-3 is a huge engine in processing it. All those approaches are cloud-based approaches, and what we've shown with some of our algorithms, and I'm told from our chief product officer that we will be publishing some of these benchmarks, but we found that the symbolic and hybrid approach actually is as competitive, and we ranked them actually in one recent test, and I think Bert was on there, and maybe Roberta. I've forgotten quite the list of all of them, but from a whole range of processes, and I think we were only sort of something of a percent off the top one, and we were second in that ranking. So you can get some very accurate approaches with this, and not all, but most of the companies I'm talking about are they've got concerns about data privacy, concerns about using the cloud, and they want control of their own data and their own models. So it's different approaches for different needs.
How interesting. It's interesting when you look at the criteria that it's not all about the big broad brushstroke. It can be about the solution that's right for a particular business, and aspects such as data privacy, which you kind of don't think of instantly if you're just focusing on which technology you think might be most suitable, but there are those considerations as well.
I mean, if you come back to the law enforcement use case, you're not going to be sending all your documents off to the cloud for that.
Thank you, Ian. Well, I think we have time for one more question. So I'd just like to understand a bit more about how you recruit and build skills in this area.
I'm not quite sure what level we bring people in. I think it's mostly sort of, or quite a lot of it is sort of graduates, but we take people in and then we train them as knowledge engineers, and but that can apply across a number of channels. So we've got partner training channels, for example, where we onboard new partners. We put them through training of the approaches, and then they become qualified to do both the symbolic and the machine learning, and put it all together in the platform.
And are there specific qualifications or topics of research during degrees and PhDs that you would find particularly useful, apart from perhaps the obvious, anything AI related?
I think you'll find there's a lot of data scientists coming out with the machine learning skills, less coming out with the symbolic skills, and I think and therefore sort of they sort of tend to be focused on a particular direction, which is I think partly why we're getting some of the answers right at the beginning of this presentation, in that annotation is a challenge, and from what the other one that scored quite highly was as well. But so that tends to lean to that focus, and I think if we can sort of broaden the church a little bit, and show what we can do with a mixed approach, I think people will be very excited with it. And I think something I sort of heard as well with what we're sort of seeing over the sort of the last 20 years is the salary of knowledge engineers is starting to climb as they become more and more in demand. So I mean, that's very much of an indication of I mean, the whole natural language processing area maturing, building a bit more momentum, and these use cases becoming real and practical.
Absolutely. So yes, of course, the data, it's so important, isn't it? And that definitely came over in the polls and in your talk. Fantastic. Well, thank you so much, Ian. This has been a really interesting presentation. I'd like to thank our speaker, Ian Wadey, for delivering such practical examples of how natural language. And I'd also like to thank our sponsors, who are from such a diverse array of businesses and are so welcoming of the variety of our content. Finally, thanks to you all for listening and providing us with your feedback and questions. Now, we've got some exciting events coming up. You should be able to see them on the screen now, and they're all detailed on the FS Club website. As usual, they reflect the incredible diversity of the subjects that we cover and our contrasting approaches to the same subjects sometimes too. At the FS Club, we are never dull, as you can see from the next lineup of talks that we've got on offer. So thank you all for joining us today. I hope you enjoy the rest of your day and that we'll see you soon.